Hello audience. Welcome to the guide to select DC-to-DC regulator for low electromagnetic interference issues. Automotive systems have several receivers, including many receivers installed around the car. International Electrotechnical Commission, IEC, has formulated international standards with the aim of protecting these in-vehicle, or peripheral installed, receivers. The international standard for this electromagnetic noise is formulated as CISPR 25, and the power supply contained in the in-vehicle module is required to meet this standard. Electromagnetic interference, EMI, is a part of it. The most of the power supply in automotive systems is a DC-to-DC converter with switching operation. The electromagnetic noise over 100 MHz, which is far higher than the switching frequency, may occur because of the switching operation and operating environment. Most of applications' switching frequency varies from 100 kHz to 2 MHz. Therefore, countermeasures to reduce this electromagnetic noise are required. Choosing the right DC-to-DC converter for automotive applications can be a challenging task when one considers all the requirements that need to be met. Now let's start discussion with relationship between EMI noise and primary power supply. In the case of radiated noise measurement of 1 GHz or less, the antenna is put on the center of the harness. The current, or voltage, of the harness, or LISN, is measured for conducted noise. The length of the harness is different from the test condition for radiation noise. Therefore, it is important to lower the level of the noise source and to prevent noise propagation to the harness to reduce the EMI noise. This harness means that a power supply line for a power supply module including power management ICs, and it is particularly important to reduce EMI noise in the primary power supply. High-frequency noise generated by switching operation. Power management ICs for automotive systems have the 2 MHz switching frequency except for some devices. Therefore, there is almost no issue in the AM radio range, 530 kHz to 1.8 MHz, as under 2 MHz, but countermeasures may be required with the over 2 MHz range frequency. Now we describes noise before explaining the countermeasure method. In particular, high-frequency noise above 30 MHz is the most important because the high-frequency current by the switching operation of the DC-to-DC converter and its path generates the high-frequency noise. This section explains the principle of high-frequency noise in each topology. Among specification requirements for DC-to-DC converter circuits, the following are considered critical. 1. Stable operation, not to be broken down by operation failures such as abnormal switching, or burnout or overvoltage. 2. High efficiency. 3. Small output ripple. 4. Good load transient response. These properties can be improved to some extent by changing the DC-to-DC converter IC and external parts. Switching frequency. The influences of switching frequency on efficiency. If the switching frequency becomes lower, the current value at the maximum efficiency moves toward the light load side. On the contrary, if the switching frequency becomes higher, the charge or discharge frequency of the FET and the IC's unique quiescent current increase. Selecting the field effect transistor, FET. Efficient DC-to-DC converter circuits may be designed by selecting the absolute maximum ratings of the voltage and the current that are equal to 1.5 to 2 times of the operating voltage and current to reduce the failure rates against spike noises and impulse noises at the switching time, and that minimize the losses by drain to source resistance and capacitance source current. Countermeasures of EMI noise. There are several ways to implement countermeasures for EMI noise reduction. We can achieve those by the setting of power management ICs, the components selection, and the PCB layout as the method that does not impact bill of material. Additional countermeasures by adding circuits and components. Shield. The shield of the DC-to-DC converter should have a height as low as possible and its size should be compact. Generally, the shield is made by a ferromagnetic material such as iron, but shielding by copper also is effective for electromagnetic field noise reduction at high frequency, 30 MHz or more, and for electric field noise reduction at low frequency, 30 MHz or less. We cannot eliminate the total electromagnetic interference from DC to DC converter, but we can select with low disturbances. Thanks for watching.